Hi, this video we're going to record ASAv Cisco MPF module policy framework to mitigate the DOS attack that we have performed a couple months ago. We have used the web DOS attack a couple months ago to attack the window and snort host itself, and then mitigate it with the host-based firewall rule. And now today we're going to repeat the same exercise. However, we're going to use the ASAv using the Cisco's module policy framework, IPS, to mitigate the same attack. Next week, we are going to use PFSense to perform exactly the same mitigations. This document is what we are going to base upon for our hands-on exercise. So you want to download this document while you're watching the video. And once you download it, the document looks like this. So the objectives of the exercise are to understand and use these IPS building into Cisco, so the models to mitigate a web-based DOS attack. And so need to introduce to us the basic regular expression, regex syntaxes, and also its functions. And it also, in another video for this week, we will also cover Wireshark. And we will use the regex regular expression to search, to actually as a filter to find out the interesting traffic that we wanted to look at. We are not going to use the regex in this ASAv exercise. This ASAv exercise, regular expression, has been mostly used in the application layers, IPS function of the implementation. Such as we are going to allow certain domain to visit. However, that function has been largely replaced by the content filter. So we are just going to go through the concept and give you some examples, but we are not going to do a hands-on exercise on that. We do well configure the network layer Cisco IPS, the module policy framework, to mitigate the web-based DOS attack. And we're going to compare the IPS rule trigger and also the active response, compare that ASAv with the PFSense. PFSense will actively block whoever triggered the array limit and make it a virus and block it. Cisco ASA is going to still allow them to ping even, just because the attacker actually have the resources constrained by launching the attack. So the communication will be slower, but you still can ping, and you cannot open more than what's already been limited for you to open the web-based applications. So that successfully mitigate that and without blocking it. That's Cisco's default behavior of the IPS. We are also going to talk about the cloud and the virtualization at the end. Now, we're just going to quickly go through the syntax here. This is syntax that related to the application layer IPS implementation. The backslash was a dot. That means that, hey, the dot usually is a special character, but we are going to really make it mean like a dot. So we put the big slash right there. So that means whatever in the .monsec.edu in your domain list one that we define, that means the website of monsec.edu. We are going to call it domain list one, and so on and so forth. And then in there, we can do, we tell them, hey, regex domain list one, and we can including monsec.edu or Moodle or Canvas.net now, or google.com or wireshark.org, nmet.org, whatever the domain you allow them to go. So we can actually define the domain that we want it to go. And then whatever we don't want them to go, we call it not allowed. The not allowed, then this is allowed. So when it's not request, when it's not the domain list one, then it's not allowed. Okay, so that's the number one rule to inspect and match condition. Let's first define what will be inspected, what kind of condition we are inspecting. We are going to not allow anything other than domain list one. And the second is we are going to apply an action once we finish the first inspection condition. We're going to define a policy here and say allow domain class policy. And we tell them that, hey, if not allow domain class has been met, we are going to reset the connection so that the user cannot go to that site, and we will lock their action. So that's the action that we want to do. And number three, we will then use what we will focus on today, define and create a layer 3 class to execute the layer 7 action policy that we actually defined previously. So we here created one called access list. You can call it any name you want, and it permits TCP any EQ ... So that means whatever the TCP transport protocol from any source, any destination, as long as it's going to the port 80 of TCP, then it's a candidate for us to inspect. Other than that, we deny. This has a special meaning though. This ACL is saying that if you match this condition, if you are the web access, right, we wanted to inspect you. Permit means we want to inspect you. If you want to go UDP or you want to go HTTPS or you FTP, go anything other than the www port 80, then deny means that we are not going to inspect you. Doesn't mean that you cannot go out. So it's just define a condition for the IPS. So it's very different than the regular ordinary access control list ACL. Then we define a class map here and to tell them that, hey, this class map, this class object actually is go by the ACL that we created. Okay, so whoever traffic coming in, as long as it meets the requirement of this access list, then it falls into this class. And this class, what we want to do is we want to define, we are going to implement it in our IPS. We have two ways to implement the IPS. Number one, the first way is to go to the global policy and then edit the class object that we created previously here. And then tell them that, hey, we want to inspect whatever in your class, the traffic that meets the traffic to be inspected. And we wanted to make sure they are in the allow class policy. Okay, so this is what we implement that. On the global policy means that, hey, it will apply to all the inbound and outbound traffic. Okay, whatever traffic coming in, whatever the traffic coming into the old interface will be subject to this global policy inspection. For instance, I have 3 interfaces in this Cisco ASA virtualized box. From outside coming in traffic, it will be subject to the inspection. When it leaves the interface to the inside, there's no inspection needed because when you come in, you've already been inspected once. There's no need to inspect you the second time since nothing got changed when I forward it out. So, and from the inside, when the return traffic from the inside going back to the outside, when you respond back, something already been changed, that's your reply. Therefore, we are going to inspect it again. And when you go out to the outside or to the DMZ or to any other location of the interface, you are not going to waste time or resources to re-inspect it again. So only inspect it once from all the interface, the inbound traffic. Inbound meaning that you sit inside a Cisco box. Everything comes into the box. It's called inbound, ingress. Okay. The second option, and of course, this is the command to actually apply it. The second option is to apply the policy to an interface, such as outside, inside, or DMZ interface. And when you apply to an interface, it's for both inbound and outbound. Okay, and this is the syntax that you applied it to the outside interface here. the previous syntax, this object to edit is the same, except that one has been added to the global policy and the other one has been added to a specific policy called outside policy we created. And then you apply the policy into the interface of outside. All right, an example here is to to show how to define an HTTP inspection policy map that will allow only certain places for you to go, and it will allow and log any HTTP traffic that it attempts to access certain websites ASP page or with certain specific characters in the URL. Then we will actually log it. So we're not going to go into the detail here, but you can see that, again, it's very similar. We first have to define, use a regex to define the text, the URL that we wanted to make it, make a log and do some reaction to it. And then we have to define, we'll have to define, hey, do you want to log it? I call the name match any URL to log. And then we actually define what's in the URL that we want to log it. And then we'll create, okay? Then we'll create a class object in here. And once we create a class object, then we'll actually put it into a policy map, and we call it HTTP policy map. And then the policy map will actually define the action of the HTTP to inspect whatever the URL that we wanted to log it. So after we do that, and we actually have to use a layer 3 implementation to carry out this inspection. So we create ACL again in here and say anything TCP, anything in accessing the www is of interest to us. Other than that, we will let you go without inspecting it. And then we will then define a class map. And then the class map actually, this traffic, we actually have to use this ACL above to make it as a checkpoint. If your traffic fit into here, then it's the object that we wanted to apply our IPS. So now, then when we apply the IPS, there's two ways to do it again. Now you go to the global policy and then add a class object that we created to it and to inspect the HTTP. And we issue the keyword service policy global, policy global. So all inbound traffic will be inspected, including this. And option 2 is applied to inside interface, for instance, and you will create inside policy. And these two commands are the same. You add the object into it, and you tell them that you wanted to inspect it. And then you apply to both inside, inbound and outbound traffic to activate your policy. Right. So that's a quick introduction for the layer 7 IPS on Cisco ASA. Now we're going to focus today on the layer 3 IPS, which is almost the second part of the application layers to implement the IPS. First, again, just like what we said before, we define an ACL to define the traffic that we want to inspect that's of interest to us. So we say IPS ACL, you can call it anything you want. It permits IP any. That means that, hey, any IP protocol from any place to any destination, we want to inspect. Okay, it doesn't mean that we'll permit you to come in or going out and nothing to do with that. This is just say that any traffic coming in, as long as it's IP, we want to inspect. Okay, and because Cisco has a deny IP any at the end, but our first line already said permit IP any, so there's no point to put a deny IP any, just like what we did before. Okay, so just say one line. So we want a 3 line. And define it, how do we find the interesting traffic? And then we put it into a class. And the class is whatever the traffic that matched our interest. And after we do that, and of course, this is the explanation here. I'll leave it to you for you to read it yourself later, but I just explained it. And then after that, we're going to just use option 1 to apply it. So we apply first one, go to the global policy, which is what we will do. Because it's more simple, and then it just go into all interfaces, all coming in, all inclusive. And whenever you come in, We inspect you. Whatever you go out, we don't care because we already inspected. Now you go to the policy, you add your object that you created that have the interesting traffic. And what action do I want? I wanted to do an IPS inline inspection. And fail open means that if my IPS fail, let all the traffic go. Don't shut it down. If you say fail close, that means, hey, if IPS fail, nothing goes in, nothing goes out. Okay, so it depends on your company policy. You may want to consider whether you want to use fail open or fail close. Most of the situation is fail open, okay? And then you apply the policy globally. And of course, you can also create an outside policy, right? And just add as an object and tell them the same action. And then you use the keyword service policy, but instead of global policy, you added the outside policy to the interface outside. Of course, you can say outside policy added to interface inside. That will work. It's just confusing. So if it's applied to an outside interface, I would like to call it outside policy. To the inside or DMZ, I'll call it accordingly to make it clear. Okay, so we are going to go to the detail of the exercise, but I'm not going to go through all those steps. I will show you during the video recording. I'll show you how to do it. And you will open the document and follow along together. I do want to go through some of the lab topology though. This lab is going to use attacker window 2016 at 10.10.10.16 to attack. I use the HTTP attack to the MetaE. The MetaE 10.01.2 has been translated to 10.10.10.2. So 10.10.10.16 and 10.10.10.219, the window 2019, the tester and attacker, they are going to access the MetaE through its translated address of the 10.10.10.2 here, okay? And we will implement, before the attack, we're going to make sure that the tester and attacker can ping the inside, can open the web page, right? And nothing got activated here to mitigate anything. That's the first stage before the attack, make sure everything's work. And then you launch the attack without any mitigations. So during the attack, see what happened. This 2016 is only attacked it. Once it's under attack, then you can no longer ping. Neither the attacker nor the tester can ping it, and none of you outside can open the web page either. That's under the DOS attack, the normal result. And then we will mitigate it and we'll see what the difference. Do you still can access it and what happened? So that's what we will go into a detail on the step-by-step instruction here. Okay, so I will move this to the side and we will have to log into Mount Horizon. And if you want internet access, you will power on the internet firewall and you will power on Windows 2016 19. 19 is our tester, right? And you will power on MetaE, which is our victim. So once you power on all this system box, we're ready to exercise. One recommendation is the ASAv, choose the first one. I clicked and go to the snapshot and click on the working live. That can bring it up really quick. Otherwise, you may have to wait 5-10 minutes for it to become active, okay? And sometimes it doesn't even work. All right, so this is the overhead that we need to get it working. So we go to the window first, go to the MetaE and make sure it's working in there. So we go to the MetaE, enter a few times, log in MSF ADMIN, MFS ADMIN, and then it's just sudo super user, okay? So MSF ADMIN again. So we got a pound sign, so we can do a nested dash TPN. That's the connection. So nothing connected for now. That's fine. So we get ready to see what's going on in the victim, and go after that. The handout I'll tell you to power on ASAv and 2016, 2019, and both 2016 and 19 we're going to open the web page and see if everything works fine. So we go to 2016, and again, we are going to log in first, of course. Now we're going to ping it. Let's see if we can ping that. And 10.10.10.2 should be, yeah. And then okay, we can go. So 10.10.10.2 in here, and then in this at this time we can actually come in here and let's take a look at that. You can see that okay, you have two establishment for your attacker. So we have regular establishment, and then we can go to Windows 19 to do the same thing. 2019. Send control alternate delete. Oh, it's already in here. That's why. We don't need this page here anymore because I log in first and I sign on to my Mosaic account to show you what is the video is related to the Wireshark and ASAv here. So we don't need this page anymore. I can actually exit it out, and then I'm just going to use the IE to do the test. And do 10.10.10.2. So we open the page and we should be able to ping it once we can open it. That's not a problem. So in here, we just do it again. And you can see that, oh, okay, we have the establishment already in there. And you can see that if you go to Windows 2016, let's just refresh it again, press F5, and you go to Meta E, and you can see that, hey, yeah, I have actually both 2016 and 2019 connected to it. The 2019 is actually if finishing the connection is been waiting. It's waiting to finish it off, and you see that after a while, Windows 16 is going to 2016 is going to finish the connection too because it's idling timeout for the web page access. Right, so you will know that it's either one or two connection, depends on the box that you used in there. Right, so I'm going to go to continue on with the exercise here. So we showed the connection in the Meta E, and we can also go to the ASAv to do that. To go to ASAv, we can go to the 2019 here because we are going to copy and paste some command into it. So may as well just use the 2016 instead of go to the console. We can do console to do that. And then here, so what I'm going to do is I'm going to connect it to the 10.10.10.53, which is the interface on the outside because all those boxes are outside and this is inside. And ASA has two interfaces, one connect inside, one connect outside 53. And the 53 is the one that we have access to. So I'm opening it up here to access accept the private certificate and Cisco, password is Cisco, and enable, no password, okay? So you can do a show connection, show con. So if you make it larger, so that probably will see better. You can see that 10.10.16 has one connection in here. So just do up arrow key and go that again. Oh, now one used, it's gone. They already left. Then you can do a show localhost tab. Show localhost, just hit enter. It will give you who is in there locally. Currently, one active before, 6 maximum before, and no one got denied. So this is just some basic information you can see in there. But we're going to just show you again how to create those. We just go in here and press F5 a few times and go to 2019 here. And we just F5 a few times to go in. So then we're going to do a show count first. And you can see that, oh, okay, good then. I do have both 219 and the 16. You can see that when I show connection, right? do a show count here, you can see that, hey, 219 has one inside connection and 16 has one connection because they both open the web page, okay? And MetaE, you can see that they have two and they both are waiting to finish. So sometimes you will say, hey, one or two connections and whatever, but basically the established is only one of them. Okay, so if you look at that, you look at the established, 16 is one. Well, this one shows two, but we'll go by the ASA connection in here. The ASA, you show one of each established connection here. Right, so we're going to continue on with the exercise. So this is before the attack, before we actually launch anything unusual, and you can have two systems, the tester and the attacker go in, and you can see how many connections it is connected, they got created. Now we're going to go to the Windows 2016. So let me show you the document here too. I'm on this page, on this particular page, page 7. This page actually asks you to go to the MetaE and ASA to show before the attack, okay? And now we're going to launch the attack like what we have done before here. And then at the ASA console, then we're going to show localhost. We don't have to put the parameter of the host so we can see the whole thing. And or you can use the show run, okay? And it will be, you will see the overwhelming connections requested or connected from the attacker, and that's what the attack generates. And then we are going to also see what happened when it's under attack for the connection. And during the attack, we're going to ping and access web page from both system box and see what the result. And the result is they will be all fail because you're under attack. That's what the OS attack is. So we're going to move this aside, and then we are going to launch the attack. So we go to 2016, and then we'll put this one on the side. And we're going to reduce it, and we're just going to go to, okay. We're going to the, see, actually the download. It's already been downloaded for you, the attacker tool. And let's extract it out. Sure. And once you extract it, there's a GUI here, GUI application, and let's run it. And once we run it, here we gotta say, hey, who's our target, right? We're going to go to our target of 10.10.10.2, which is our victim. And we're going to do 10,000 attack and 4,000 connection rate. All right, and run the attack. So once we run the attack, then we go to MetaE here and go up arrow key to do that. And you can see that if you do this with a pipe, more or less, and you can see that, hey, more, you got a lot of connections. And you can see you got so many connections connected by the attacker 10.10.10.16 in here, and it's all established. And then in that case, in your Windows 2019 here. Now, if we try to go to if we go to the command prompt and try to ping it, then you wouldn't be able to because all the resources being used up on the server here. So I'm going to reduce it on the side and come here. And if I do an F5 to refresh, you can see that keep running, but it just doesn't have time to respond to you. Okay, so it can tell you that it cannot reach the page now. It failed. Now we go here and we do a show count again, and here you can see this overwhelming connection on those requests from the attacker, which is the 16, right? 10.10.16 box. And you can do a show local tab host, and you can see that local host, it got a lot of connection in here, right? Tons of those connections, all from the attacker. Okay. So that tells you that the conclusion of that. Let's stop the attack. So cancel the attack. Now, once we cancel it, and let's go ahead and take a look at our document here. So during our attack on this particular page, which is page 8, during the attack, you show a local host without with or without the parameter of the host itself. It's all taken by the attacker anyways. It's overwhelmed connections from the attacker. And when you go to netstat.tn, go to MetaE, it shows you the same thing. So you're under attack, and you cannot ping or cannot open all well file because it's under attack, which is a normal result. And now what we will do is we want to mitigate it. We're going to set it and say, hey, we define a class map. And then we are going to make sure we are going to apply the class map into the global policy. And we are going to set the service policy to global, means that everything comes in, it's going to subject to this policy. And this policy is going to set the rate limit of connection and say, hey, maximum connection is 200, maximum set connection max and connection max is 100, but then per client, I want to make it 5 only. So if the attacker keep requesting it within certain time limit, then you can only have maximum of 5 connections. And we're going to see that. And so we can reserve the resources for other normal ordinary requests. Okay, so this is the policy that we use to mitigate the attack. Now to apply the policy, then we will have to go in here, highlight the whole thing, and right click, and we say copy. Okay, so let's move it to the side. And we can, of course, let's cancel the tag already, I guess, and leave this alone. We're just going to 2019 and come in here. Let's apply to it. So yeah, let's go config T. Okay, so ignore all the other errors because we use the evaluation license. I already requested a license, so if the division approved, we can actually update the license later. So once you are on the config mode, right, and right click, it doesn't work that way. So we have to come here and go to the notepad. I think WordPad probably better. Okay, because of the enter key and stuff. So let's paste it. Whoop, didn't get copy, huh? So let's do it one more time. Go to the Word document. And this Word document is here that I downloaded on the host. Right clicked and copy. Got in here, right clicked, and we paste it in. It worked. So highlight it again, right clicked and copy. Have to go through probably 2 steps. Okay, it worked now. Okay, so if it doesn't directly paste into it, just go ahead and paste it into your WordPad and then paste it back in. That's the reason why at the beginning of the class, I actually used this Windows 2019 to sign on to my Canvas and then downloaded the document so I can actually copy and paste into a Windows 2019 box. Okay. All right, so we're going to reduce this. And so now we're ready to mitigate it. In that case, so what we're going to do is we're going to go to the Windows 2016 now, run the attack again. So this time when you run the attack, you can see that it fixed F5 now, okay? And then if you want to ping it in here, it's going to be very slow. You can see that because you already using the Windows 2016 use most of the resources to launch the attack. So the communication between that and the Cisco box is pretty slow. And then so we're not going to wait here. We're going to here. We're going to Windows 19 again and go to the command prompt. You see during the attack it failed, but now you mitigate it. Therefore, the ping become very successful quickly. And then come in here, it was cannot reach the page, and now it was perfectly fine. So now if we go to the Cisco box here and we do a show connection, show con, now you can see it's clear. All right, I have 1 connection for the 219, and I got 5 connections maximum that's set up for the 2016 the attacker. So 1 for the tester, 5 for the attacker, because we set a rate limit of 5. Now you go to Meta E, it should show you the same thing. And it have 246, yeah, absolutely. So you see, we have 5 established because it was keep connecting, and this one it's idling there. If you want to see established, you just go to the 2019 here, and go here, and then you probably press F5 a few times here, and then you go to Meta E, and you just quickly do up arrow key, and we'll 2, 4, 6, 7. Ah, okay, here. So you see 7 now. And here you can tell this one is established because I refresh it so many times. So it's still connected, but there's some leftover to finish the time wait. So you may see 5, 6, or 7. The most is 6 of the established. Okay, so that's just the because of your browser connected, and then when it's not active, then the established become time wait to finished, fin wait or time wait. Okay, if we do it, up arrow key, click it once, up arrow key, up arrow key, and do it again. Yeah, so it becomes 2 time wait, and then the establishment is gone. Yeah, and yeah. All right, let's see. Yeah, and then you see the other one disappear. Okay, we're not going to spend more time on that, but go by the Windows. The ASA is pretty good and accurate because they keep counting that. And if you do a show localhost, and you can see there is show counts there, and then if we do a show localhost, and you can see that it tells you from the 16 what happened to it, and then for 2019, Windows 2019, then you have a number of 1 connection in here, and then for the Windows 16 attacker, you have 5 connection in there. So it tells you some detail on that, and if you don't want the detail, just say show connection. Okay. And now, of course, timeout for the Windows 2019 tester. So you only see the attackers still maintaining the 5 connections in here. All right, so if you see that, yeah, it does slowly get an ICMP response back, but the resource is slow. So if you cancel the attack, then in here, you're going to see it, ping quick, and everything is back to normal. And then in the 2019 here, you are going to see when you do the show count, click here, we do show count here. You will see that, hey, nothing connected now because you already canceled the attack. But again, if you go to here and then we go to IE, we go in here and we do a few of the refreshing for that. And if you go to your 2019, then of course you will be able to see the connection. Regularly, it's just 1 connection, and then if you wanted to refresh this one also, then you're going to see both the testers. You see both of the connections in there. So this is back to the normal, and it's already mitigated. So, all right, let's take a look at the document here. So once we mitigate it, we launched the attack and we did run the test again. The tester, they are able to. Will the tester be able to? Yes, because the now resources has been reserved. We are no longer giving more resources than needed. We give them only 5 connections to the attacker, so we can actually respond to the ping, and we can actually let you open the web page. Yes. Will the attacker do that? The attacker cannot open the web page because the rate limit has been reached. So if we try that, it wouldn't be able to. The ping was low because of the resources constrained by the attacker itself. And then on the ASA console, I did show you the show run, show con, and the show local host to show the connection from both the tester and the attacker. And it will show established 5 connection for the attacker, and from the attacker, and 1 from the tester. The established, the keyword is like that is in ASAv. In the meta-E, you will have time, weight, and but in any case, the established is 5 and 1. Okay, 5 and 1 of the connection for tester. If you go to the IE and do a refresh really quick. I don't want to use a Chrome to do that, because sometimes it didn't actually go out. It just stay in the cache, become fancy, and so your test won't be reflecting the real communication between the remote host and the web server itself. And so that concludes the attack has been successfully mitigated. So the attacker, the main point, the takeaway is that the attacker will not be able to open the web page more than it's already been allowed. But the other requests, like a ping and other requests, they still can come in. However, it will be slower because you are actually using a lot of resources to that. But the rest of the world will see normal response. Okay, that's the end of the lab, and now we're going to talk about the next generation firewall or security appliances and devices, which will integrate all the firewall intrusion preventions and application firewall application IPS, different application for different purpose, and you can add it as module, and in the next generation, we call it next gen firewall, and also the cloud services and virtualization is one of the trend as well. One of the very important thing that's affecting our IPS in specific is that when we virtualized all the VMs, it resides mostly in a physical server or a few stack up server, but it's inside a physical machine as a virtual image. Then the issue is when all the VMs on the same network, that's the key, okay? When all the VM on the same network, on the same NIC card, then the traffic actually didn't go out of the interface. So when we say, hey, apply the interface coming in, coming out, then sometimes we have issues. So if we want to protect the server from the same station on the same network, that's why we sometimes have to consider, okay, if you want to implement that with IPS, you want to separate your server into a different network, server network. Like in a Cisco hierarchy network design, the top level is the core switch, core network that will have all the file server in there. And then your workstation will be in different places, go through a high-speed connection at different network to access the server. And in that sense, then the data will flow from a different interface and going into the different interface of the ASA to actually implement the intrusion prevention system. So when we virtualize it, there are certain limitations and certain changes that we have to consider. Okay, that concludes our exercise. Thank you.